This is section 5-4, starting on page 239. We're talking about factoring polynomials. And in this video, we'll be talking about factoring polynomials using the greatest common factor and factoring using grouping. So greatest common factor. Greatest common factor is the biggest number you can pull out of each term. So let's look at our trinomial. We have 6x squared y squared minus 2xy squared plus 6x cubed y. And this is example 1 on page 239. First thing we're going to look at is our coefficient. Our first term we have a 6, our second one we have a negative 2, and our third we have a positive 6. So the greatest common factor we can pull out of all these numbers is a 2. So let's start with that. So then we have 2 as our greatest common factor for our coefficient. And inside of parentheses, we're left with x squared y squared minus, 3x squared y squared minus xy squared plus 3x cubed y, close parentheses. We have two terms with a 3, but our other term does not have a 3, so that's why we can only pull out a 2. Now let's look at our x's. In our first term we have x squared, our second term we have just x, and the third term we have x cubed. So the greatest common factor to each of these terms is just an x. So we can pull one x out of each of these terms. So outside of parentheses, we now have 2x open 3xy squared, because we started with an x squared and we can only pull one out, so that's why I have just an x. And our next term is minus xy squared, so we can pull out that one x. So now we have minus y squared. And our last term is 3x cubed y, pull one of those x's out, and we have plus 3x squared y, close parentheses. So now I have 2x open 3x y squared minus y squared plus 3x squared y. So we've taken care of our coefficient, we've taken care of our x. Now let's look at our y's. Our first term has a y squared, our second term has a y squared, but our third term only has a y. So we can only pull one y out of each term. So outside the parentheses we have 2x, and now we have 2xy, open parentheses, 3xy squared, pull out one of those y's, we have 3xy, minus y squared, pull out one y, so we have minus y, plus 3x squared y, we have one y to pull out, so we're left with 3x squared. So that is our completely factored out polynomial. So we have 2xy times 3xy minus y plus 3x squared. Okay, now let's talk about factoring using grouping. This is example 2 on page 240. So we have a 4-term polynomial, a cubed minus 4a squared plus 3a minus 12. So let's pull together as many of like terms as we can. We're going to group using our associative property. So let's take the highest number of exponents on our a term and put those together. So we have an a cubed and we have a minus 4a squared. So let's put those guys inside the parentheses. We have open a cubed minus 4a squared, close parentheses, plus what we have left over is open parentheses 3a minus 12. Now let's talk about what this actually means. Okay, so let's pull this apart. We're looking for a greatest common factor to each of these terms. We have a cubed minus 4a squared plus 3a minus 12. Is there something we can pull out of each one of these terms to create a greatest common factor for each term? So what can we pull out of a cubed minus 4a squared? We can actually pull out an a squared because each term has at least an a squared. So that looks like, open parentheses, a squared, close parentheses, open, a minus 4 is what's left inside. Plus, okay, so now we have an a squared and we have an a minus 4. In our second term, we have 3a minus 12. Now, somehow, can we either make an a squared out of this or an a minus 4? Well, if we have 3a minus 12, we have the greatest common factor in this term of 3. So we can pull that 3 out, and let's see what happens. So now we have 3, open parentheses, a minus 4. Because 3 goes into 12 4 times. Now let's look what we have. We have a squared times a minus 4 plus 3 times a minus 4. So now we're looking at this. We have a minus 4 times and another a minus 4. We can regroup this as two binomials being multiplied together because we have a common term to each one, a minus 4. So we can rewrite this as open a squared plus 3, close parentheses, times a minus 4. And we only need the instance of a minus 4 once because we have our a squared and our plus 3, which is in front of each of our terms, represented inside those parentheses.